My name is Dimitri. I am research fellow at Aston University, where we, as a part of the Europa conception, participate in developing new non-invasive methods of specific brain disorder diagnostics. The Global Disease Study estimates that about a third of the population worldwide is affected by brain disorders, and in European Union, more than 80 million people are affected by brain disorders, including Huntington and Alzheimer's disease. In such brain disorders, the key paradigm is the early diagnosis that could slow disease progression and subsequent disability. However, it is highly difficult to detect early symptoms. The majority of us have seen movies, cartoons, and comics novels about superheroes. Now imagine that your GP got a see-through vision like a Superman or superhero from fantastic film. He could detect any abnormalities in your brain without wasting time for additional procedures. Wait if I tell you that now it's possible to provide doctors with this ability, using a new methods of non-invasive diagnostics. Here at Aston University, we are engaging in the development of laser source for non-invasive system that is capable to get inside the human brain. The Europa consortium has assembled to develop a conceptual novel non-invasive diagnostic approach. We will develop a non-invasive system which modulates long-term activity in specific cortical-subcortical networks implicated in specific brain disorders. This will be achieved by two-photon activation of novel phytochrome actuators that control the expression of genes involved in synaptic plasticity. We will develop an ultra-short pulse system utilizing advanced compact laser in the near-infrared spectral range specifically for brain activation. The skull is semi-transparent in the wavelength range of 1 to 1.7 micron. Therefore, we aim to be able to excite phytochromes non-invasively, ensued in real time. Changes in local cerebral blood flow induced by the result neuronal activity will be monitored non-invasively using the near-infrared diffusion wave spectroscopy technique, which will provide a measure of phytochrome stimulating effect and enable to control of brain activity. To activate non-invasively the bacterial and plant photoactivators like phytochrome in brain cells through scalp and skull, we develop several ultrafast fiber lasers at mid-infrared wavelengths, invisible for human eye, which however allow us to reach the greatest penetration depth in brain layers. The fiber-based laser design is highly adaptable and more compact than many of their counterparts. The amplified spontaneous emission bandwidth of rare earth elements doesn't cover the required wavelengths to excite phytochrome produced in brain cells. However, non-linear effects in optical fibers can provide a frequency conversion of laser gazing, which will at the end give us required mid-infrared short pulse irradiation, more transparent for scalp and skull, which will hit phytochrome and as a result activate neurons. For me, as a researcher in optics, it is a challenging task to develop the high-efficiency compact laser source with the required parameters to provide the top of the skin and scalp penetration ability.